Chapter 2, Configuring a Network Operating System. So we're going to look at what a network operating system is, what is the purpose of Cisco's IOS, which happens to be Cisco's operating system, explain how to access and navigate such operating system. We're going to describe the command structure. We're going to look at how to do some basic configuration like hostname, maybe some preventative level of access, so being able to set access controls. We're going to look at how to save configurations, both a current configuration versus a historical running configuration. We're going to explain how the devices communicate across network media, how to set an IP address for a host device, and if time, how to do that for a device. We have this broken down into introductions, which we just did, iOS Bootcamp, getting basic addressing scheme, and we're going to finish up the summary. So iOS Bootcamp. You have to remember that all devices, whether it be networking or printer or computer, they all have an operating system. It's going to be what runs that particular hardware. So all networking equipment depends on a specific operating system, whether it be Cisco's iOS, Juniper's JunoOS, or any of the other ones that are out there. Cisco, obviously, their iOS is a collection of networking operating systems used by Cisco devices. Cisco IOS is just one of many. So what is an operating system? Normally, an operating system comprised of a few different levels. A shell, a kernel, hardware. Those are important concepts for our operating system. So the shell is going to be what we, the user, interfaces with. And that allows the user to request specific tasks. And those requests can be made through either a CLI, command line, or even a GUI. Most Cisco IOS devices will be done through a CLI. Though there are GUIs out there for Cisco products, it's just they're not always the best. Underneath our shell, or what allows intermediary to connect between us and the physical hardware, is what we know as a kernel. And this kernel communicates between the hardware and the software. And this manages how the hardware resources are used by the software in the most efficient means. The hardware is the physical portion of the computer, and that includes all of the underlying electronics. So again, we interact with the shell. The kernel takes the input between the shell and the hardware. So the purpose of an operating system? It's just so that the end user has a way to interact with hardware, not directly, but through some type of controllable means, the kernel. That could be as simple as being able to move a mouse. You move the mouse, the software has to interpret that and then figure out what you meant. Switches or router iOS provides similar options, and normally that is how the device is going to react. And we do that through configuration interfaces. We could also enable specific functions such as specific routing or switching functions, or filtering based off of needs. Again, all devices have an operating system, and just like most things that came before it, there are ways to upgrade the current operating system to a newer operating system. So, for our course, we're mainly focusing on Cisco's iOS release 15.x. That's just one version. It happens to be the 15th major version, but they're going to keep coming out. So maybe in a few years, maybe next year, maybe later this year, they may have the release 16. Not sure. So where is the operating system stored? In a hard drive, it's stored in some type of long-term storage hard drive. In a Cisco device, normally they are stored in flash. Flash is going to be non-volatile storage, meaning it won't lose its settings or won't lose the storage when power is lost. It can be changed or overwritten as needed or requested. It can be used to store multiple versions of an IOS. That way you can tell it what iOS to load. The iOS is copied from flash to the volatile RAM when necessary. The quantity of flash and RAM memory determines what iOS can be used. Different iOS functions could be things like specific features that our device needs. Like, do we need security features? Do we need routing features? Do we need quality of service or QoS services? What about addressing or interfaces? These are all major functions of our OS. Next, how do we program it? Normally we program it via some form of console. That's if we physically want to connect to it. But we could also connect to a specific address if we have a port assigned an IP address. We may be able to connect to that IP address through that port through the network so we can communicate with it. So console is physically connected to the console port, or we could telnet or virtually connect through a virtual terminal through an already defined port. So our console port normally is always defined as console, and sometimes called out-of-band access, and that refers to the access via a dedicated management channel, and that is for maintenance purposes only. In the event that a password is lost, you can bypass the security on the device and console into it. Again, there's going to be a procedure to bypass that password so that you can do it. Normally you need a specialized console cable known as a console cable that allows you to configure specific commands, such as configuring a password. That way not anyone can gain access to that console port. One nice thing about the console port is, as long as your router is physically secure, then this console port should not be able to be easily accessed. Other methods could be Telnet, which is again a remote access CLI over a network, meaning you have an IP set up, but this is all clear text. So we have this other option called Secure Shell or SSH, similar to Telnet, but it's more secure. Next is some type of an auxiliary port, similar to a console port, because it's used for out-of-band connections, and you can set this to use telephone lines. Terminal emulation programs, if we don't have Hyperterminal, which is built into older versions of Windows, you could use something such as PuTTY, or TerraTerm, or Secure CRT, or OSX Terminal. Normally, PuTTY is one of the big ones, Hyperterminal is a good one. Cisco normally has you use TerraTerm, but it's just kind of preference. Next is our actual hierarchy. So we start off with a user exec mode, and that's going to be denoted by caret. And you can do limited commands at this area. You can have to do a show to see what commands are limited or what commands are offered here. You can do ping, you can do enable, you can do a show, which again is very limited. Enable allows you to go from our user exec mode to our privileged exec mode. And you're going to notice that our caret's going to change. And again, when you do show here, you're going to see a lot more commands that are offered here. And if you actually want to configure a specific portion, you can actually do that configuration here. For example, configure terminal would allow you to go to our global configuration mode, and that's going to be the name of the router and config and our pound. And from there, you can start programming more specific items. Again, we're going to get more into this when we get to our lab, but just recognize that it's a hierarchy. This command can only be ran at this level. It cannot be ran at this level. It's very structured. Primary modes, again, are user exec mode with a caret, and you will gain privileged mode by typing enable, and that will take you to the device and a pound. The user exec is very limited, but does exist. The privileged exec mode allows you to have more privileged commands. So things like from our privileged mode, we can actually go from our caret to our pound, and then we can actually get to our global configuration mode that allows us to configure things for the entire device. If you want to configure specific components of the device, you may have a specific type of configuration mode. For example, config -mode. If we want to configure an interface, we'd go from our global configuration mode, type interface, the name of the interface, and that allows us to actually program that interface. That will bump us down to config -interface. That way we can configure that specific interface. So when you first get in, you're going to notice a caret. Enable allows you to go from the caret to the pound. If we disable or exit, we'll go back from our pound back to our caret. So that's basic navigation between the different IOS modes, from user exec to privilege exec, back and forth. And then configure terminal again gets you from our exec mode to our global configuration mode. So let's do some breakdown of our IOS command structure. Switch is the name or the prompt. That should be a caret or a pound. That's all part of the prompt. Then we may have a command space argument. And that argument could be multiple spaces. So if you're never sure, you can always do question mark. Question mark should give you the next portion of our command. Cisco is very popular, so there is an IOS Command Reference. You can actually Google it or go to Cisco's website, and those are the steps to gain help. So we said question mark. You can actually, if you're not sure, you can start typing out a command without a space and question mark, and it'll give you those options. Here we have CL question mark. You're not sure if it's talking about clear or clock because they both start with CL. If we're talking about a specific explanation or a command structure, we could actually do clock space set space question mark, and that's actually going to tell you what the next command is or the structure of that. So it may want you to set the current time, and that's going to be in the mode of hours, minutes, seconds. So let's assume we already have clock set the time, then what? Could be the month. Now, how do they want the actual layout of that month to function? So you can do this clock set, hit enter, and it should show you incomplete command because they're still expecting more. For example, clock set is looking for the time and date. So understanding what the output is giving you is kind of important. So that's different from ambiguous command. because an incomplete command is expecting more. Ambiguous command means it's looking for more. Like C, what starts with C? Lots of commands will start with C, so it's not sure what command you're talking about. So let's go back to invalid. So clock, set, time, day, month. It doesn't understand what after the day is. It's expecting the actual month spelled out. So you putting 6, even though it's June, it doesn't understand 6. It's expecting you to type June. Some specific hotkeys that are important are tabs. If you type in CL and hit tab, it's going to give you ambiguous. It's not sure if you mean clear or clock. But if you do CLO, only one command starts with CLO, and that's clock. So instead of having you retype or type the rest of it, you could hit tab, and that will actually finish typing out the rest of the command for you. Control A moves to the beginning of a line. Control Z exits the configuration mode and returns back to user exec mode. You can also down arrow and up arrow, so you can scroll through former commands you've done. Control Shift 6 allows the user to interrupt an iOS process such as ping or traceroute, or Control C will exit the concurrent configuration, or will abort the current command. So you got some options. So iOS examination commands, we can do show, but show what? Show version gives us some operating system commands. If we're doing show process, we can actually see the program. Show CDP neighbor will show you different portions of all of this. And we get more familiar with the show commands as we're doing them. So, show run config versus show startup config. Startup config is a configuration that loads at startup, but as you make changes until you save them, they're not part of the startup config, they're part of the running config. So if you power cycle your device before saving them, it will just load the past startup config. Show version, for example, will show you the specific Cisco IOS software, what iOS software is being ran, and the version. Moving on to 2.2, getting basics. Okay, so let's get some basics down. Let's focus on creating a small 2PC network. So we can do this between 2 PCs and 2 switches. So we can actually start limiting access to our devices. We can start a basic configuration so that if we do gain access to the device, we have some type of banner or message showing what it is. So normally some guidelines is we start with a letter, we do no spaces, we end with a letter or digit, use only letters, digits, and dashes, has to be less than 64 characters in length. Without host names, network devices are difficult to identify for configuration purposes. For example, if you don't know that this is switch 1 on floor A of a specific building, it might make it harder to configure if you're doing it remotely. If you're doing it on site, it might be a security precaution. It just kind of depends. Normally best practice is name them appropriately. So here we have switch for floor 1, switch for floor 2, switch for floor 3, and that way we kind of know what they are. So how do we configure the host name? We do that by, first of all, going from user mode to exec mode, from exec mode going to global configuration by again typing configure terminal. Once we're there, we can change the name by typing in host name and our host name, sw-floor-1, and you'll notice the prompt changes from switch, that's the current name, to the new name of switch floor 1. So we've already talked about things like securing them, but there's different ways to secure them. We can enable a password, and that will limit access to the privilege exec mode. We can enable secret, and that will encrypt and limit access to the privilege exec mode. The difference between password and secret: password is plain text, secret is a hash. We can set a console password, so this will limit device access using the console connection, or we could also limit connection by putting a VTY password, and again that's going to be the passwords via Telnet or SSH. So again, to go from our user mode, enable, to our privilege exec mode, or from our privilege exec mode to our global mode, we do configure terminal, or you can actually start shorting these, not typing out the entire command. So instead of typing out configure terminal, you can do bare minimum CONF. That makes the command not ambiguous. There's only one command that starts with CONF, and that's configure, and that changes to our configuration mode. If we want to enable secret, we could type here in our global configuration, enable secret password. Here the password is class. If we want to do the same command but in clear text, we could do enable password and then the password. If we want to set specific commands for our lines, again, from here, we're already expecting that we're in our global configuration mode, because again, notice the prompt. That lets us know global configuration. We could do line console 0. We could put a password on it. Or we could put a password on the VTY. So line VTY, how many virtual connections? We have 16 possible, so 0 to 15, and we set a password there. The console port must be secured. It reduces the chance of unauthorized access physically plugging into it. However, again, if we're talking remote access through Telnet or SSH, that's going to be our VTY. So encrypting password display. So if you do a show run, and these are secret passwords, they're actually going to show just this hash mark, not the actual password. Next, let's talk about the banner. Banners are important. You want to make sure that all your devices have a banner set. And the banner could be as simple as, this is a secure system, authorized access only. So how we do that is we type banner, MOTD, message of the day, and some type of special character. Normally pound or ampersand or %, and we type out our message. Then we end it with the same special character. That's how we set a message of the day banner. If we want to see the current configuration, we could type show running configuration. That will show the running configuration. But how do we save that to our save configuration? We can actually do that from our exec mode, and we do that by copy run config space startup config. That allows us to copy the running configuration to the startup configuration. So there's a few more things that we need to know. Reload will actually let you reload the device. We can erase the startup config by typing erase startup config. That deletes all of these basic settings. If we're talking about switches, there's a VLAN database, which we haven't talked about VLANs yet, and I understand that. But there's one file that's important to realize is vlan.dats. We could delete that by typing delete vlan.dats, and that allows us to delete all of the current VLAN information. Again, I understand we have not talked about VLANs, but that's a command that normally at least stayed at this level, so you know how to delete it. The vlan.dat stores information about VLANs on switches. If we're looking at text, you can actually capture the output. So you could do a show run config, and then you could save that output. Next step is basic addressing schemes. All devices have to have an address. Each end device must be configured with an IP address and subnet mask, and normally a gateway. It's input in such a way where it's going to be 4 groups of 8 bits, normally in decimal, and this is going to be called dotted decimal form. So our decimal dot, our decimal dot, decimal dot, decimal. Because each group is 8 bits, we can have any number between 0 and 255 in each group, or in each octet. Octet is each group of 8s. The IP address needs a subnet mask because it is necessary. IP addresses can be assigned to both physical and virtual interfaces. So, an interface or port is the network communications depending on an interface or port, and that's just basically how things connect to them. So there are different types of media, included copper, fiber. Now that copper could be twisted pair or coax, or even wireless. Wireless is not a physical media, but it's still a networking media. And each different type has specific characteristics and pros and cons. Ethernet is the most common LAN technology, and that uses twisted pair. Ethernet is the protocol that it uses. Ethernet ports are found on end-user devices, switch devices, and most general networking devices. Because again, it's going to be the most common. Cisco IOS switches have physical ports as well as virtual ports. Obviously, a virtual port has no physical hardware connecting to it. That switched virtual interface allows you to manage it remotely. So we can configure our virtual interface with an IP and subnet mask and the VLAN that it's on, or the management group that it's on. And we do that by typing interface VLAN 1, assuming 1 is the appropriate VLAN. That's the default management one, just so that you know. The next command is going to be IP address, the IP address, and the subnet mask. Then we tell it to turn itself on by issuing the no shutdown command. That allows us to turn on that IP address on that virtual interface. If we want to turn it off, we type no. If we want to turn it on, it's no shutdown. If we want to turn it off, it's shutdown. Here it is in our command line. Interface VLAN 1, that's the interface. Then we type an IP address and the appropriate IP address. We can manually assign IP addresses to end devices by going to the network connection. IP address, subnet mask, and default gateway. Again, the default gateway is the router IP address. You can manually set these, or you can have them automatically assigned by something called DHCP. Sometimes there are address conflicts, and normally Windows is smart enough to realize that and so it'll prompt us. We can test our connectivity by pinging a loopback address. The loopback address is 127.0.0.1. That's essentially saying, hey, let's ping myself. That way we can make sure that our network interface or NIC card is functioning correctly. Now, how do we know if we get all of the interfaces connected? We can do on the device a show IP interface brief, and that will show us the interface, the address, if it's okay, the method, the status, and the protocol. The protocol is normally the physical wiring. Status could be the administrative functionality. Is it administrative up or down? And that applies for even virtual interfaces. We can ping from our user exec mode, notice the caret, and we type in the appropriate address and it pings. And that is actually it for this chapter. I want to thank you and you have a great day.